Everybody, and this is a brief introduction about the three types of stepper motors. I'm going to explain each one in uh, brief details. First, there are three different types of stepper motors. First, we have the permanent magnet and the variable reluctance, and the last one is the hybrid. First, what is stepper motors and why they are special? Stepper motors are mainly used in applications as we see here in robotic arms. And unlike servo motors, it's open loop, which means that they do not need sensors to give them feedback about where their position are. And they are very accurate, and this is how they can be open loop, as they know each step they take, and their accuracy reaches to 1.8 degrees. So that's why they don't need an feedback to know the exact position. First of all is the permanent magnet, which is permanent magnet stepper motor. As we can see in the diagram, it has north pole and south pole, and stepper motor by a circuit controls which stator, which is the stationary part, and the rotor is the rotating part, which stator receives the current. And we know by these windings, when current passes through these windings, we tend to have a magnetic field, and the magnetic field has north and south according to the direction of the current. So the circuit organizes it as the stator receives south pole when we want the north pole to go to it. As we can see here from B, if B is its south polarity, then the rotor, north side of the rotor, will turn to the south side of the stator. And if we increase the stator, this will increase accuracy. As we can see here, each time it will rotate about 90 degrees, so its accuracy is about 90 degrees. Next up is the variable reluctancy. As there is a great example in the internet from Learn Engineering and Live Free. Basically, variable reluctancy is unlike permanent magnet. It does not have a magnet, but it has a rotor is made of laminated steel, or this type of material, iron. It could also be iron. And how it works is it has a magnetic field, and magnetic field or magnetic flux tends to have the shortest path, and this is the meaning of magnetic reluctancy is magnetic resistance. So as an example made by Live Free, he shows exactly that the magnetic flux moves through this C-shaped, but it has nothing at the bottom except this bolt. So for the magnetic flux to flow smoothly, the bolt has to be aligned with it. And this is how we can, of course, we control where the current goes to each stator. So, and this is what is create the currents, of course. But what I want to say is, if we have multiples of these, then we can control the rotor going each direction to each one. And yeah, the path is fixed for the C shape except for the bolt. And we have here an air gap. The shorter is it, the better, as it will help the bolt to move faster. The last step is the hybrid stepper motor. What it has, it combines both the principle of permanent magnet and reluctancy. As we can see from this picture, rotor 1 on the right hand side, rotor 1, rotor 2, it has two rotors, and inside them they have a permanent magnet with a north side and a south side. And they are organized in a way that their teeth are not perfectly aligned, or not most of them aligned. As we can see from the on the left side picture, of course these pictures I got them from Mechanisms and Mechanical Devices by Neil and Nicholas, if you want to read for further information and reference. As we can see on the left side, they're both vertical. They are perfectly aligned teeth of the rotor and teeth of the stator. But the other tooth is not 100% organized. Some of them are deviating by little, and some of them are completely deviated. And by passing the current through this part and other part, we can create a similar effect in the previous two rotors, where like they attract and then they repel. The rotors are like mini magnets, as this picture I have taken from the Learn Engineering, and the hybrid is the most popular one, and it can reach accuracy of 1.8 and 3.6 degrees per each step. And yes, this is it was a basic introduction to the three different types of stepper motors, and I hope it benefited you. Thank you.